Good morning. This is Steve Cantrell with DBA Fundamentals. First presentation in September. And today we have Bert Wagner, and he'll be speaking about refactoring queries for improved performance. And I'm actually really looking forward to this. I look forward to all of them, don't get me wrong, but I think I'm going to learn a lot from this one. As you see on the front page there is our tweets. If you want to tweet us questions, we'll try to get back to you. I know that you'll probably want to be speaking to the speakers, and if you want to ask questions, ask plenty of questions during this session. If we actually need to go over time, we'll go over time with Bert and let him finish all his questions. And you can also see our other sites. dbafund.org will get you to our website, our YouTube site, Twitter site, Slack, and LinkedIn. We have sponsors, and these sponsors help fund these presentations. In fact, they pretty well take care of it. Plus, they give us the ability to give away money and give away sessions, which I don't think we ever advertised it that we were going to give away a session for today's attendance. But what I'm going to do is we have 2 full past sessions to give away. We may have 3. But what I'm going to do is everybody that shows up at this session is going to be put in a pot. And everybody that shows up at the next session is going to be put in a pot. And we're going to give away 2 out of that. You guys have the possibility of getting a free, full paid past summit. And we'll be doing that probably after the next session. And if we get the 3rd one, which we may do, then we'll give that away in the first session in October. Anyway, back to Century One. They're a great sponsor. Go to their website. They'll give you all sorts of help with their articles, helpful resources. They'll answer query tuning advice for you. Century One, the Plan Explorer is fantastic. You need to utilize that. In fact, in refactoring queries and looking at execution plans, it's so much easier working with Plan Explorer than Microsoft's. So definitely take a look at that. DB Watch is one of our other sponsors, and they have a lot of good software that helps monitor full enterprises across SQL, Oracle, everything. So it's a little bit different situation. There's their website if you want to go to it, and they've got free trials that you can download and try out, and they've got great technical support to help you. PASS has lots of virtual groups. This is probably an up-to-date. They've dropped some of them in the past, and they're trying to concentrate on certain ones a little bit more, but they have them in multiple languages, and they have them on pretty well most of the important topics. So you can take a look at that and go try out virtual groups on PASS and get a lot of other presentations and a lot of other resources. Okay, I was talking about the past summit, and the reason that we have got 2 full summits to give away is because we're leading in the discount code contest, which gives us some money to help give away and run on, and it also gives us the ability to win full pass summits for free. We have one more deadline coming up after September the 13th of this week. The price goes up $200 more. Everybody that has used our discount code, and right now we've had it used 52 times, will be put in a pot, and we will draw out one person that will win $300 extra. So If you've used our code already, great, you're still entered in that contest. And if you want to use it before September the 13th and save what little money you can save after that, there's no more discounts. And the price doesn't go down any. It's going to stay the same. This is as much as it would cost you if you went to the door and paid it. It'll be $22.49 even with our discount after the fact. It's $20.49 right now. So use our discount code VGDISM843. Okay, now on to Bert. Bert is one of the up and comers in being able to present and present great content out there in YouTube world. I'm not sure if he's in other places, but he's got a lot of great content. You need to go check out his site. I'm sure he's going to show you some stuff about it. But I've been noticing him in the last year or two, and he's got great content. We actually utilized him early in the year for some sessions to where we were doing little 3 and 5 minute sessions before things started. And we might start doing that again if we get some people sending some questions to DBA Fundamentals and let us know that it was something that you really liked. He had some great stuff that was not necessarily on topic that we were having, but anyway, he's going to be talking to us about refactoring queries. And I'm sorry I haven't done a great job on this presentation. I'm kind of out of practice, but anyway, thank you, and let me transfer it over to Bert.
Cool. Thank you, Steve. I thought you did a great job.
I didn't make any stupid errors that I've been known to do.
Hey, that's half the battle right there. So.
Yeah. Okay, let me make you the presenter. Here we go. Let me know.
All right. Let me know when you can see my screen there.
I see it.
Cool. All right.
Thank you.
Well, let's do it
now.
All right. Thanks, Steve. So welcome everyone. Thanks for joining in today. Like Steve mentioned, we're going to be talking about refactoring queries to get better performance. And the motivation for this presentation, let's just skip right ahead here, right, is typically there's 3 broad categories of performance tuning to make your queries run faster. And the kind of highest level one, the one that gives you the most performance benefit with as little configuration changes as possible, right, is manipulating your server and database settings. So things like your max stop and your cost threshold for parallelism, right? If you get all those settings right on the server or at the database level, all of your queries will benefit. They'll all hopefully perform better, and you will, see improvement across the board. So typically that's where people start, making sure their configuration, all their settings are set up right. But once you get past that, once you start looking at, at a more granular level, things people typically look at next are indexes and adding indexes and perhaps modifying existing indexes or deleting indexes to get more query performance. And that's by far my most favorite way of performance tuning is figuring out and optimizing indexes. But as you'll see on one of my next slides here, it's not always possible to deal with indexes, to create new indexes. There's a lot of situations where you just simply can't do that. And so what you're left with is, if you can't modify server and database settings and you can't modify index, what your indexes are, the only thing you really have left are your queries yourselves and refactoring those queries. And that's what today's presentation is going to be on. For sure, right, if you have the ability to do things like modify indexes and server settings, then that's where you should probably start. That's usually where the root cause of many problems begin. But in situations where you can't, that's where today's presentation will help you out. And so as Steve introduced me earlier, right, I'm Bert Wagner. I'm a YouTuber and blogger. I make weekly YouTube videos about SQL Server. So if this presentation is your style and you learn something from it, be sure to check out my website and YouTube channel. You can learn a lot more. And if you are interested, these slides and all the demo code we're going to look at, there's a lot of demos today. All that's already uploaded at my site there at that URL that forwards to my GitHub profile. So you can, download everything you need there and play around with these examples on your own. So getting right into it, like I mentioned, you can't always get what you want, right? You can't modify those server settings and you can't modify indexes for performance reasons, right? One of the big occurrences of this that prevents, for example, changing indexes is something like vendor databases. I work with a lot of vendor databases, and per the contract and agreement, we're not supposed to touch them at all. And even if that means your table has very poorly created indexes or sometimes no indexes at all, if you're not allowed to modify those data sources in any way, change into the objects on the database, then you're kind of stuck just looking at the queries. We've also encountered plenty of times where you may have a fragile system. So I think about like a data warehouse that is so overburdened and has been working for so long and is so critical to the business that changing things on it is a scary proposition, and maybe changing something is going to take a really long time. So you don't want to change things and add indexes and things like that. You want to just work on the queries. Additionally, sometimes your systems may just not have enough disk space, right? If you're dealing with gigantic tables, billions of records, terabytes of data, it may not always be easy to get disk space or get the disk space when you need it, right? Once again, long term, if you can add an index, that's definitely the way to go. But in the short term, if it's just not possible because you don't have any free space allocated, you may have to revert to a query tuning technique to actually improve performance. The same thing, kind of old hardware. If you're stuck on old hardware and you can't do anything, you can't use some newer features, then it's, you're kind of out of luck. Also, if you're supporting users who maybe, analysts or their tool set doesn't necessarily align with SQL Server Management Studio, maybe they're not as much of an expert to be able to recommend their own indexes or what they're able to do. Or maybe they just, if you are an analyst and you have no ability to recommend that indexes be added or server settings be changed, you may just have to be stuck with being fine with tuning your queries. So finally, one of the things I more recently encountered is sometimes your SQL servers may have certain security software installed on them, and those security tools may prevent certain features within SQL Server to be used, basically forcing you to downgrade what is available. So once again, all of these reasons, right, are just a lot of different reasons why you maybe have to focus on refactoring your queries. And so today we're gonna briefly talk about these first two things about, why the optimizer has problems and why it generates poor performing queries sometimes. We'll briefly touch on query hints and trace flags, but most of the rest of the session will be demos of some of the most common refactoring techniques that I use and how you can use them too. So diving right in, right? SQL Server and SQL just as a language is a declarative language. And so what that means is, right, you write your queries, you specify what you want back, what data you want brought back, but you don't necessarily tell SQL Server how to get that data. The how, right, is left up to the optimizer to determine what, an efficient way of retrieving that data is. And the way the optimizer works is it relies on a set of assumptions about the data and about data in general to kind of come up with plans for retrieving the data that you ask of it in a fairly efficient way. The problems start happening though when those assumptions and what the optimizer knows about your data are inaccurate, right? So things like if you have, outdated or inadequate statistics on your indexes, they're providing information to the optimizer that doesn't really reflect the true nature of your data, the optimizer is going to start making some bad choices. And like I mentioned earlier in this presentation, right, ideally we would always fix the root causes of these problems, like updating our statistics or adding additional statistics if we need them, or in some cases, right, if an index is missing, an optimizer, right, can't seek to the data it needs maybe, it would be better to just add a missing index. So always try to fix those root causes, but sometimes when you can't, that's when we have to kind of trick the optimizer into doing something else. And finally, and just one point, my last bullet point here is, right, some queries are just too complicated. So the optimizer has a really tough job of trying to come up with a plan in just, maybe a few hundred milliseconds of how to get this data. And if you're submitting queries that are just these gigantic walls of text with plenty of nesting and joining and everything else, the optimizer might just give up and end up with a plan that is not ideal because it didn't have enough time to really, understand that gigantic query that you're submitting. And so we'll look at ways to kind of remedy that as well. And like I mentioned, quick word on query hints and trace flags. I know a lot of people like using them, and I'm not opposed to them, especially, right, trace flags if they're well documented, if you understand fully what they're doing and they are fixing the specific problem that you're setting out to fix. I don't have a problem with that. And same thing with query hints, right? Query hints are a way to actually tell the optimizer to do something that it wouldn't do on its own. The problem with these things, though, are when you overuse them or you don't use them with the necessary precautions that they require, right? Forcing every single one of your queries with query hints to do something else will, in the long term, just create lots of problems. You may end up breaking your queries, right? Especially, I always think of the cases where you're forcing like an index to get used or something, and then that index name changes or something down the road. Your queries are just going to break. And so while I think things like query hints are fine to use in like a all hands on deck, everything's on fire, we need to get this problem fixed immediately, let's throw a query hint on it to just get things working again. Long term, I don't like using them in production code because of the consequences that they potentially have. So today's session will not really focus on any of these because I don't like using them. And so what we will focus on instead are these set of demos, and I'll hop over to SSMS here in a minute. And just a few quick words about these demos. There we go. You should be able to see my SSMS window now. If you're not, let me know, Steve. But I've always wanted to do this presentation because as I was kind of growing as a SQL developer, I always had to tune queries without knowing, without being able to do things like create indexes. It just turned out a lot of the environments I was in, that was my life. And so over the years, through various other people's presentations and conference sessions and user group meetings and virtual group meetings, right, you learn these kind of tricks all over the place, but I never had one unified source that I could reference to kind of know, what options do I have available. And so that was part of the reason this presentation came to be, was because I wanted, especially for newer SQL Server users, to kind of have a reference of these. They are tricks. They're kind of hackish tricks. You don't want to use them every single day, but it's good to know them, that they exist for when you do have to use them. So creating that reference was important to me, but then the other fun part was that actually creating the demos for this presentation took a lot longer than I thought, because while I commonly see these problems in the wild, right, in my actual production queries, being able to replicate them on example data sets definitely took a little bit more work. So for these demos, you'll notice a couple things. All of my demos are going to be running with MaxDop 1. I didn't want to get into parallelism too much with these demos and overcomplicate them. Additionally, the data set I'm using is the Stack Overflow database. If you're, hopefully you're familiar with Stack Overflow, right? It's a question and answer site. So don't need to discuss too many of the tables we'll be using, but this badges one comes up a lot. So on the Stack Overflow website, you can win different kind of awards known as badges, and that's what data exists in this table here. So it's just like, a most liked question or most liked answer, right, would be the type of badge you would see in there. And the other tables that you'll see are things like posts and users, which are pretty self-explanatory. Posts containing questions and answers on this web from the Stack Overflow website, and users are the user profiles of the website itself. And so we'll go through these demos, and then the last thing is I have pre-ran all these queries because I want to try to get through as many demos as we can in the next 30-40 minutes here. So I didn't want to spend time running very poor performing queries. So if you download these demos as well, you can run them, they should work, but you'll see we will be looking at pre-saved execution plans just to save some time. And so for this first demo, what I want to talk about are window functions. So if you're unfamiliar with window functions, right, that's whenever we have this over clause. So here I'm using the first value window function. And what I'm trying to do is figure out who's the first person to earn each badge. So what user ID was the first one to earn each different type of badge. And so the initial way I would write this query, right, since SQL Server 2012, is to use something like a window function to use this first value over partition by syntax to get my answer. I like using window functions because they make writing these types of queries very simple and very quick, but they do sometimes have some downsides, as we'll see in a minute. So if we actually go and run this query, let's take a look at the execution plan for it. Like I mentioned, here it is. We don't have to wait for this to run. Some of these queries in these demos took minutes and minutes and minutes to run, so we get to kind of skip that and just look at the plans themselves. And you'll notice this plan right from the beginning, when we have our cluster index scan, we are reading 8 million rows, right, in this table. So we're scanning the whole table, and that's fine because our query is asking for that, right? It's asking for the first user ID for every badge name that exists. And you'll see we immediately get a sort, and that sort is needed in order to get to our window spool function. And just a quick word about some of the costs here in our execution plans. You'll see the sort is a 90% relative cost to all the other operators in this plan. And while, yes, that sort of 8 million rows is really bad, there are some other misleading operators in here with costs that, like this window spool, that's a 2%. It may not look like that big of a deal. 2% is nowhere near 90%, but this window spool is creating a lot of writing to tempdb. So we are seeing problems there. Without getting into this too much, if we just quickly jump back to our query window, we'll see I turned on statistics, IO, and time on before running these queries. And we'll see that this query with the window function here, we have our 46,000 logical page reads that are happening from our clustered index scan on our badges table. And that's what we expect, right? We didn't filter our data. There's no where clause, so there's not much we can do about scanning the whole table there. But we do have that work table, right, with what is 66 million logical reads happening on it. And that work table, right, is getting generated in tempdb. That's happening when that sort, you saw that it spilled to tempdb, and we had to write to it, and then we had to read from it, and it was causing all kinds of problems. And that sort specifically is needed in order for our partition and our order by functions here to work. So overall, while this query was easy to write, using a window function, and like I said, that's always my preference to at least try a window function first. The performance wasn't great, and on my machine when I ran this before, it took, you could see 47 seconds of CPU time, so not great. So the first way that we can kind of rewrite this, in all these examples, we're going to take a look at common query scenarios and how you can potentially improve their performance through refactoring. So the way I would refactor this query is actually really simple if you've been using SQL Server for more than just a few years. And that technique is, right, just writing the query the old-fashioned way. And what I mean by that is, in a time long ago, before window functions existed in SQL Server, you would frequently have to write queries that looked like this. this kind of template of having your group by with your aggregate functions nested inside of a subquery, right, that you're then joining back onto another set of data. Kind of writing things the old-fashioned way, as if those window functions didn't exist, can coax the query optimizer to give you a different type of query plan that will end up giving you the same results. So when you do have window functions that are performing poorly, one thing you can try is just doing a query rewrite to do things the old-fashioned way. And so if we check the output of this query, it would give us the same exact results. There's absolutely no difference in terms of the result set. And it is uglier. It's more of a pain to write. It's not just a few lines that we had in our window function. But if we look at our statistics, time, and I/O, the first thing we'll see is that this query took less than a second to run, right, compared to 47 seconds. And a big reason for that is if we actually see our I/O here, is the number of pages that SQL Server had to read into memory is just the 46,000, which is the whole clustered index, because we don't have any where predicates. But you'll notice that there's no work table here, right? There's no data being written to tempdb. There's no data being read from tempdb. We avoided those 66 million pages of data that were previously going to tempdb. And if we look at the execution plan for this, of why maybe that's happening, as we'll see, it's a much abbreviated execution plan. There's no sort that's spilling to tempdb. There's a lot fewer operators. You'll see that there's no spool. There's for that window function, our data doesn't have to be sorted in any particular order. And overall, right, our data here, you could see we go from 8 million rows very quickly down to the actual 30,000 rows that we return for our distinct number of badges for each user. And so if there's one thing, right, that I can sum up this demo with this example, is it not only applies to window functions, but when you have a window function and you're getting poor performance, as nice as that easy to use window syntax is, sometimes you are just better off rewriting the query as if window functions didn't exist. And you may be able to get a different plan out of the optimizer that hopefully will be better. And in this case, as well as all the other cases, rewriting the queries this way, sometimes your plans will get better, sometimes they'll get worse. There's no way to really know without trying it out first. So that's that. All right, this next set of demos I'd like to look at is regarding correlated subqueries. So a lot of times when I see newer SQL users write queries, they'll use this kind of syntax here, where in our select statement, we're setting the value of some alias equal to a subquery here. And so in this case, we're trying to answer the question, when was each user's first badge awarded? So once again, we're going out to that badges table, and we just want to figure out for each user, when did they get their first badge? And one way to write this query is with this correlated subquery. And once again, right, the benefits here are that it's kind of easy to understand what's happening, right? We're returning our user ID, our distinct user ID, and we're going for each user ID, returning the minimum date from the badges table. And this works fine. It returns the data we need. If we look at some of the attributes of this, right? So this query took almost 8 seconds to run on our CPU when I ran this previously. So not terrible, but if we go and look at the execution plan for it, we'll notice a couple interesting things. So first thing we're doing, right, is here we have 2 scans on our badges index, and you can see here, right, we got all 8 million rows coming through again. And one of the best things you could do when performance tuning queries, right, is to reduce the amount of data your query needs as quickly as possible, right? Filter it out as soon as possible. The thing that's happening in this plan is, you could tell by the arrow sizes here that our data isn't being reduced that quickly at all, right? So we start with 8 million reads on our index scans, and here once we get to our join, we're joining 8 million rows with a reduced 1 million rows. But because it's a write out or join, our output of our join operator is still 8 million rows. So up to this point, right, we're still dealing with our full table size of data. We're then computing a value for 8 million rows of data before we're actually able to do our aggregate and reduce that from 8 million down to 1 million. So a big problem with this execution plan here is that the way we've written this query, SQL Server can't reduce the data until the very last step here, until our hash match. Ideally, we would like to write this in some way that would prevent that. And the reason this is happening, whenever you write a correlated subquery, right, whenever you have this kind of subquery in your select statement that's joining back to the rows in your outer table, it's basically like telling SQL Server, run this query in a loop. For each of my users in my outer table, go and execute this other query. It's like running a very slow cursor. So what we can do to rewrite this style of query is just get rid of the correlated subquery nature, right? So once again, if we rewrite that, we'll see we basically took that subquery that was in our select statement and just moved it down to our from. We added an inner join, we changed our join to down here, but that's really, right, all that happened is we took the query out of the select, moved it to the from, and if we go ahead and run this, you'll see, right, our CPU time was only 5 seconds in this case. So we gained 33% speed, and it definitely runs faster. If we go look at the execution plan for this example, right, we'll see once again a more abbreviated plan, and it's still not great, right? Because in this case, right, if we look at our row counts, we have 8 million rows. Our hash match goes down to 1 million, so that's good. Here we have 8 million down to 1 million, and we do our join, right? And that's only 1 million. So that's what attributed the speed boost there, is that we are filtering our data sooner and not having to execute it in kind of that looping fashion like our correlated subquery was doing. But at this point, it's a great time to point out that when you are in this kind of query refactoring process, it is good to always take a closer look at your queries, right? So we just rewrote this query to move our correlated subquery into our from, and it did give us a performance boost, but it's still maybe not as fast as it could be. Whenever you are refactoring queries, maybe they're from someone else, right, who wrote this query long ago and they had different requirements than you. And now when you're writing this query in the present, maybe requirements have changed, and you'll notice that, hey, maybe there's some duplication going on here, right? So for example, here I'm getting my dates from the badges table, and I'm just joining it back to the badges table. I'm not really getting any other fields from my badges table here. It just seems kind of redundant that I'm doing this. And if you actually look closer at it, it is redundant, right? We don't actually need to do that inner subquery anymore. We could actually just get rid of it and move our aggregate min function to our select, and this query will actually give us the same exact rows. You'll see the execution of it right now drops down to 3 seconds, so we save a little bit more time. And looking at the execution plan, right, it gets even simpler. We've eliminated that join. We go down from our 8 million rows to our 1 million rows very quickly without any other steps. So the lesson there is, right, not just rewriting your correlated subqueries to more regular queries with your subqueries and your froms, but always take a closer look to see if you can really simplify the query. Don't just go on autopilot. See if you can get rid of some other subqueries. Maybe when you wrote this long ago, you didn't know some of the techniques you know now, or whoever the developer of that query wasn't aware, or requirements have changed, right? So always take a closer look and see if that's possible, because in this case, this is a much more simplified version of that query, right, which will perform better. All right. Moving on to our next demo here. This is an interesting one. So in this demo, we want to basically return some data on users that have these particular badges, right? We want to return some fields from badges where the badge name is benefactor, and we want to return some where the name is research assistant. And if we run those two queries just on their own, first of all, it's interesting because we get two very different plans. And the reason this happens, we can go into it a little bit more later on if we have time, but basically, I'm trying to get there we go. So this top query is our query where name is benefactor. This bottom query is where the name is research assistant. We get two different plans for these two different values because of our data distribution. In the case of benefactor, SQL Server decides there's so many rows with benefactor, I'm just going to go ahead and scan the whole clustered index to retrieve my rows. Where in the case for research assistant, we have a non-covering index available here. And so what happens is SQL Server decides, hey, you know what, I'm going to look up the research assistant rows in my non-covering index, and then the remaining data that I need, the fields that aren't included in that index, I'm going to go look them up in my clustered index down here. So based on the values that we're passing into our queries here, we're getting two very different execution plans. But now what's interesting is if we want to combine these two queries, right, which we ran separately up here, and we want to combine them into a single query, we may use something like an in statement. We could use name, name equals benefactor or name equals research assistant. It would give us the same kind of output. But if we combine both queries, so our predicates are just kind of in one predicate there, we'll see we get a different execution plan. In this case, oops, sorry, did I click the right one? Yes, I'm sorry. In this case, we get our nope. And I think I closed. Let's check here. And I won't. Okay, here's our execution plan for these queries, right? Where name is in benefactor and research assistant, we see we get some index seeks and key lookups. So previously, where SQL Server would have ideally done two different plans, when we combine both of those values into a single query statement, we get one compromised execution plan. It maybe is ideal for one of these values, but not for both of them. So in cases like this, where you have these kind of non-covering indexes, one thing you can try doing is joining your data together by using a union all instead. So instead of moving that benefactor value and that research assistant value into the same where clause, we can just keep these two queries totally separate and join them together with a union all. And if we go ahead and look at what the result of that is this kind of execution plan. We're getting our clustered index scan for one value here, and if you look down in the predicate section of this little box, you'll see the value there is benefactor, where we're still doing a key lookup for our where our predicate is research assistant, and then we're just concatenating them together. So in this case, SQL Server is kind of using the best method for each of these different scenarios. And so that's just one thing to kind of keep in mind whenever you are faced with this kind of or predicate or an in predicate. You can try instead using a union all to get a different execution plan, and that plan may improve performance or it may make it worse. You won't know until you test it. Okay, moving right along. This example is probably one of the most used examples of query factoring when you can't do things like modify indexes. I use this technique probably more than any other that I'm showing you today, and it has greatly, saved me in a lot of instances where I was having performance problems. So let's take a look at the query we're trying to refactor here. So in this case, I'm using a CTE, or common table expression. I like CTEs. I like the way they kind of divide up the syntax of the query. They make it easier to read. And so in this case, I'm creating a common table expression called January 2010 badges, where I am just filtering on my badges table to only my January dates, and February 1st is included. I don't know why I included that. That's just the way it is. But then I'm trying to use the results of this query, right? This 1 month of data that I'm selecting to filter on some questions, right? So imagine this query is maybe going to a website with some paginated report values. And so in each of these expressions following, I'm getting the next 10 popular questions, notable questions, and stellar questions, right? Those are all just different badge names. And I'm doing that by going back and querying my January 2010 badges expression at the top here, where I'm filtering on those different badge names. And I'm using an offset, right, to get page 2 of my results. The point here is it doesn't really matter what this is doing. This is just a common technique I see, especially maybe among analysts who are writing very large queries to be able to process a lot of data at once, where we're selecting a subset of data in our base kind of common table expression, and then we're doing some manipulations on that data in our resulting or in our subsequent common table expressions. At the very end, right, maybe we're unioning all that data together to finally get our output. And probably the biggest problem with this, and it is if we look at this, right, our logical reads, we've got 100,000 logical reads on our badges table. What's happening is a lot of times people will think that if they kind of fence in their subquery like this, right, where I say I'm going to select my data, only 1 month of data in my initial common table expression, my resulting queries will only run on that 1 month of data. And in some other relational database systems, right, that is how it works. And sometimes it works in SQL Server in certain scenarios, but most of the time, that's not what actually happens, right? And I'll prove it to you. If we actually go to an execution plan here, this is the execution plan for that query. So you can kind of see each one of these rows of operators is running the expression for a different badge name, for a different where predicate. And in each of these cases, you'll see here, right, we're doing a clustered index scan on our badges table, and we're having to scan all 8 million rows. For this second example here, we once again are having to scan our 8 million rows just to filter down on our 1 month of data. And then later on, we filter on the specific badge name. And then in this last example, in this case, we're not filtering on we're not scanning the entire index, but SQL Server is doing an index with a key lookup. But overall, right, this is a lot of work. It's not that SQL Server is going back for any of these queries and just getting the data from some kind of temporary result set that this first expression created. This is just syntactic sugar for SQL Server, right? It makes it easy for you to maybe write the query this way to be able to reference this expression called January 2010 badges, but behind the scenes, SQL Server is always going back to the badges table and having to rescan the clustered index to first find the data in this date range before then applying your name filter here. And so that isn't good for our performance, right? Like we said, we're in this case where we have 100,000 logical reads, we're constantly going back to scan the clustered index. It's not great. Instead, what we can do is use a technique called divide and conquer, is what I've heard it called from Jeff Moden. And this is really cool, right? This is where we're taking our giant query and kind of breaking it up into multiple parts to make it easier for the SQL optimizer, query optimizer, to be able to kind of create a better plan and reuse data in a more efficient way. So in this case, instead of creating a common table expression for our January 2010 results, we're actually just going to create a temporary table in tempdb with the columns we need, and we're going to index it, right? So here I'm adding a clustered index to my data, and I've indexed it based on what I'm joining on in my subsequent queries. And then we're actually going to load that 1 month of data into our temporary table. So in that case, SQL Server is still going to scan our entire badges table, which is in only about 50,000 rows, and insert it into tempdb. So there's no real advantage there. However, the advantage comes with the rest of our query. So now we have these 3 kind of expressions here in our common table expressions, right, where we are filtering on this January 2010 data. But instead of going back to that clustered index every time, SQL Server is now just going back to that temp table that we created on January 2010 badges. And so what ends up happening in this case, so let's take a look at the execution plan. In this case, we still have our 3 rows of data, but now you'll see we're doing clustered index seeks on our January 2010 badges temp table for each one of these rows. And what that means is that instead of having to scan and read 8 million rows, 2 times or 3 times, here we are only reading 20 rows. And in this example, we're also only reading 20 rows. And in this example, we're only reading 8 rows. So while that initial cluster index scan still happens in order to populate our January 2010 table up here, for all of these subsequent queries, we are referencing a much smaller result set. And it's not only a much smaller result set, but we were able to index that much smaller result set so that we get index seeks and everything performs much faster. And so like I mentioned very early on in this presentation, sometimes the queries you send to SQL Server are just so gigantic that the query optimizer can't possibly figure out an efficient way to get the data to you in an efficient manner. Well, this type of technique, this divide and conquer technique with temporary tables, is a great way to help SQL Server identify, how to kind of break apart your query and to perform the different parts of your queries in a series of steps. You create a temp table, you load it, you read from that temp table, maybe then you populate the next temp table and you kind of go through that. Because each step is much simpler for the query optimizer to kind of take apart and interpret, it's more likely that you'll get better plans. And even though you are writing to TempDB, the overall performance of your query will be much better. Like I mentioned, that's a technique I have used over and over again. All right, let's go through one more demo, and then I'll make sure we have a little bit of time at the end for questions in case anyone has them. We'll finish my little PowerPoint here. But this is also one example of a technique that has saved me numerous amounts of times, especially on large data warehouse servers. In particular, servers where there's truly enormous amounts of data, and maybe you as the user have a better understanding of the data, but because there are so many different users using the system, because there's already so many different indexes on the system, adding custom indexes to get things to run faster is just out of the question because the system's already overburdened. So one thing you can do is, if you truly know your data better than the server does, is potentially forcing join orders. And we're not going to use a query hint to force our join order. There is a query hint that allows you to do that. But like I said, I'm not a fan of query hints. There's other techniques that you can use to do this. And I first learned this technique from a presentation by Adam Mechanic. I've actually linked to it here. All of these demos actually have plenty of links and references and notes that you can reference. So if you want to learn more on a particular topic, you can. But this is a technique that I love. So in this example, I have this query and I'm joining 3 tables of data together. I'm joining users and badges and posts. And if I run that, let's just look at the execution plan. So the order of my tables, very important here in my from, is users, badges, and posts. But if we go look at the execution plan, we'll see, in this case, SQL Server does grab the badges and users tables first, it joins them together, and then it joins the posts in. So we happen to get lucky and it is joining the tables in the order that we wanted to. But let's say we don't want that order, right? Let's say we know something about our data and we know that SQL Server should really join users and posts first, right? We think that that'll filter the data down much quicker so that when it goes to join on the badges table, it'll result in a faster join. So what maybe we can try to do is something like add parentheses around our table joins. If we add the parentheses, maybe we think we can coax SQL Server into joining users and posts first before we join badges then. But if we actually run this, we'll get the same exact execution plan as here. It will not actually follow our parentheses. There's no order of operations for table joins. Once again, SQL Server is a declarative or SQL is a declarative language, so it doesn't matter how you write that, the order of your tables in your from clause. SQL Server is going to join the tables in whatever order it thinks is best. And so no amount of parentheses or anything like that will actually force these tables to join in a different order than what SQL Server decides is best. The one way around this, though, is to add some kind of blocking operator into our one of our tables. And so one way of doing this is by doing something like a select top on our post table. And what that does is, since we are saying select top from posts and we're joining with users, SQL Server has no other option but to first perform this join between posts and users, because it's taking a top number of rows, and then it will go back and join in badges. You'll see the number I used here. This is from that Atom Mechanic presentation, right? It's a funny number. It's the max, int number 2 billion, whatever. The point of that here is that it kind of catches your eye that this is not like a business logic, right? It's not select top 100 or 10,000 or something that maybe is there for the actual logical purposes of running the query. This is here to draw your attention and to read, the comment that you documented saying that, hey, this number is actually way bigger than the number of rows that are in posts, right? We'll never have that many numbers in posts here. So this is purely just to add a blocking top operator to force the posts and users to join together first. If we actually look at the execution plan for that, we should see, I'm sorry, I clicked the wrong one. Here we'll see users and posts are joined together first, so that then SQL Server can do that top 2 billion. Our top is our blocking operator in this case, but it did force the join order to change before we then go back up here to join with our badges table. And the great thing about using this kind of blocking operator technique is that it will not cause your query to fail if something changes, like a query hint might, or if you're hinting at certain indexes to be used or something like that. Those potentially could fail long term. Whereas this, it will not fail. Your query might, perform poorly at some point, but you're not going to have a catastrophic failure. So using this technique of kind of adding a blocking operator like a top is one way you can force the join order of your tables to change from what SQL Server thinks it should be. All right, last couple minutes here. Jump back to my PowerPoint slides. So we went through most of these demos. Like I mentioned, all these demos are available online as well. And I just want to be clear that this is not, it doesn't even scratch the surface of what you can do to rewrite queries. These demos were kind of the more interesting, the more common examples that I've seen, maybe ones that need a little bit more explanation, so they're suitable for this type of presentation. But to kind of quickly go over a few others, right? You can do things like convert UDFs to have, to be inline logic. So if you have different UDFs that are maybe running sequentially, inlining that logic could improve performance. Same thing with scalar functions. Trying things like distinct versus group by. They're not necessarily doing the same thing, but a lot of times they'll return the same result set. So I've linked to a great article there by Aaron Bertrand that you can read about, where in certain cases you'll get the same results using those two different techniques, but one of them will have a drastically different plan than the other. Same thing, another linked article with not in versus not exists, and when you want to use each. Too long didn't read of that, is that not exists will be faster most of the time. You can use things like materialized views. You can change your cardinality estimators. You can copy your data or have a secondary that you're copying data to, that where you can add indexes and change the data, right? There's a lot of different ways to be clever about how to manipulate your data in some way where even if you can't change the structure of your database with indexes or change the server settings in the source location of your data, there are ways to refactor the queries or change other things like copy the data that will give you better performance. And so with that, I think we have a couple minutes left. If anyone has questions, I'd be happy to try to answer them. But otherwise, thank you all for tuning in. Hopefully you found this enjoyable, and yeah, thanks.
All right, thanks very much, Bert.
Yeah.
We got a couple of questions if you have time to answer them.
Sure, I'll do my best.
I suppose the first one kind of harks back to the very start of the presentation, where you said there's a couple of server level settings that you could set. Somebody just wants to know if you'd mind shouting out what they were again.
Yeah, I mean, so things like your max degrees of parallelism and cost threshold for parallelism. I mean, those are two big ones where I think like the default settings that ship with SQL Server are generally considered to not be good for modern workloads running on modern hardware. So, if you're setting up a new box with just the defaults, do yourself a favor and check those two settings first. Other things would be things like, your settings for ad hoc workloads. If you are working on a database that is getting lots of ad hoc queries to it, explore those types of settings because they will give you much better performance for all your queries rather than just, the one query you spend an hour tuning like we talked about today.
Yeah, that's fair enough. That's actually a good one, going back to your CTE demo. And I'll actually say when I first learned of CTEs, I put them everywhere thinking they were amazing. But somebody would like to know what the difference would be with using a table variable or a temp table in place of a CTE.
Yeah, so there's a lot of different differences, and I think those differences are getting smaller and smaller with every new SQL Server release, right? Especially with 2019. I know a lot of the table variables and temp tables are getting much better, but in terms of similarities. But a lot of the problems you could experience with a temp variable, I think, come from the way SQL Server estimates the data that exists in that temp variable. If you create a temp table, the statistics and the indexes, right, that exist on that temp table are typically much more accurate than you would get from a temp table, from a table variable, I'm sorry. And so you'll get the optimizer to give you, much better execution plans.
Okay, that's great. This is a nice one. It's kind of what your opinion would be. How would you identify slow running queries? Or what do you use for that?
Yeah, I mean, there's a lot of different tools out there. It just depends on, what your budget is and what you like using. Personally, I've always liked the Brent Ozar SP, Blitz set of queries that are free, that whole health kit. There's some ones in there. I like using those, but I mean, if you have monitoring software on your server, like, SQL Sentry or anything like that, I mean, that's great for finding, historically slow queries and things like that. It just depends, whatever you have to work with is the best tool.
Exactly, and as long as you know how to use it as well.
But yeah, that's also very important.
Okay, I'm gonna read this one as it is, and I think I'll leave it up to you how to interpret it. So on a query where you're getting two different query plans based on the value distribution, how might you decide what to use in a production scenario where that value is not known at design time?
Yeah, so it to me that sounds like maybe a parameter sniffing kind of question, maybe. I don't know if that's how you were interpreting it, Shane, but that's what I think of is typically with different data distributions and you're getting radically different execution plans. If you were to run those kind of values standalone, parameter sniffing's tough. There's a lot of different techniques you can use. You can set the default parameters. You can obviously recompile if you're okay with having SQL Server spend extra time on the CPU calculating a new plan every single time. It's really hard to give a general answer. I think it depends on your particular scenario because, I mean, for me, as an example, a lot of the queries when I encounter parameter sniffing, option recompile, right, is the right answer, even though the whole SQL Server community, says option recompile is terrible. Well, it's terrible if you're running on, high throughput servers with lots of queries running all the time. If you have extra CPU capacity, that could be an okay solution. So it really depends. I don't want to give just one straight answer because it'll be wrong for someone.
Yeah, there's no real catch-all.
No.
And like you said, option recompile, it mightn't work in all situations, but if you can take that CPU hit, you're happy out.
Yeah.
Okay. There's a question here. What, if you wouldn't mind saying, like, what is new in SQL 2017 or SQL 2019? And what would you look forward to as well for performance tuning?
Yeah, I mean, there's a lot with how, I mean, the one example here, right, which will hopefully become obsolete, is where I mentioned, inline your scalar function logic into, your query. The optimizer seems like it's been improved, especially for 2019. I am not an expert in all the 2019 features out there. I'll leave that to all the SQL Server consultants of the world who have time to play with that. I'm more of a meat and potatoes, get my queries running today rather than at some point in the future. Maybe I'll get onto SQL Server 2019. So I'm not the best person to ask. I know there are lots of great features coming out, but I'm not an expert on them all.
Yeah, that's fair enough. There's always what's it called, drinking from the hose pipe. There's so much to learn.
Yeah.
Just one more, because I actually kind of like the question. Somebody says, I see you hovering on each of the items in the execution plan. Which operator do you look out for?
That's a great question. I actually I finished up a blog post series and a video series on how I kind of walk through and troubleshoot my queries using execution plans. So if you go to my site, they should be, the past 2 or 3 posts and videos. The big ones for me are always just, there's caveats behind all of these. So just know, don't always do this, but things like if you are expecting clustered index seeks or index seeks in general, and you're getting lots of scans, right? Or you're expecting scans, but you're seeing seeks with lookups, right? Those are things to check out. Spools, anytime I see a spool anywhere in a query, it always causes me to investigate further, because usually those spools, right, you're writing to tempdb, and that's one of the slowest things that can happen as part of a query execution, so you want to try to avoid that. Looking at the types of join operators that are used, right, so there's 3 types of joins that can happen in SQL Server: nested loops joins, merge joins, and hash joins. And if I see a lot of hash match joins in particular, sometimes they're a necessary evil because they're able to process large amounts of data, and that's the only way that SQL Server can handle it. But if I'm seeing only hash match joins, it's more likely a problem of things aren't indexed well, data isn't coming back in pre-sorted order. So like I said, there's a lot of things. Those are probably my top ones that I look at. But if you go to my website, you'll see I had a whole 5-post series on reading through execution plans and what operators to specifically look out for.
That's great. That's perfect. And that actually works out as well, because some of the questions are, where can we find the scripts for your demos? And I point them to your website and YouTube channel as well.
Yeah.
Perfect. I think that's all the questions, because most of the comments coming in are saying thank you and great presentation. Yeah. So I think I'll leave the questions there.
Perfect. Well, thank you for everyone, for tuning in and for having me. It was great. And thank you, Shane and Steve, everyone else, for kind of moderating and setting it all up.
Bert, thanks. You were wonderful. And everybody, this is just the tip of the iceberg. You need to go to his YouTube site. He's got tons of other information, and you'll love it. And he keeps a lot of short videos too, so you can find a ton of information and real quickly. So anyway, Shane, I'll let you close it out. Well, I'll close it out since you've muted yourself. Anyway, thanks. Remember our discount code. Remember, this week, at the end of the week, it's the last day before it goes up $200 more. Thanks again, everybody. Bye.